So last Wednesday we talked about annuities, right? Which are these sorts of savings plans that you make regular payments into them, and you start off with for annuities you start off with a balance of 0, and you make payments into them. And as you make payments into them, the amount of money that you have already put in there at any given time is gaining interest, and so it's sort of helping you along because the interest is sort of going in the same direction as your payments, right? They're both increasing, your overall balance. The money that you're putting in and the interest that money is gaining. Today we're going to talk about something kind of analogous to it, which are loans, credit cards, which are essentially a type of loan from the bank, and mortgages, which are just a type of loan that is specifically for a house. So they're all actually just kinds of loans. So just as a quick thing, so an annuity or a savings plan, which we talked about last Wednesday, it's marked by regular payments. You start with a balance of 0. And you work up to an amount. You pay, a certain amount of payments in the hopes of getting to some final amount. And the interest is helping you because it's moving in the same direction as your payments. Now, on the other hand, a loan, in many ways it works the same way, right? You make regular payments. There is interest, although how that interest works is a little bit, it's a little bit opposite. For loans, you start with a balance, right? The balance that you borrow. You start with some sort of balance, and you try to work down to 0. Right? Because you want to pay off the loan. You want to make it so that the loan does not exist anymore. So you're sort of moving in the opposite direction. And while you're paying it off, the amount that you have yet to pay off is gaining interest that you have to pay this time, right? It's not interest that you get to keep, it's interest that you have to pay for having that outstanding balance that you haven't yet, paid off as part of the loan. So the interest is in the opposite direction as to your payments. You're making payments to try to make the loan go down, the interest is making the loan go up. Which is why it's in your interest, to pay off loans as fast as possible. As payments. So you're making payments to try to make the loan go down. The interest that the bank is charging is making the loan go up, so that you have to pay, more. So you're fighting the interest, right, when it comes to a loan, whereas the interest is helping you when you're talking about, saving your own money. So that's going to be the difference, and you'll see that both the formula for finding out a loan payment and the method for using the calculator to sort of, solve some variable in the loan payment are very similar. They're just a tiny bit different. But fundamentally, right, that's the differences between what we talked about before and what we're going to talk about today. Okay. So, when we talk about loans, the principle has much the same interpretation as when we talk about, depositing money or, saving, gaining interest on some amount of money. It's the amount of money owed at any particular time. It's just how much ever is left of the original money that you borrowed. So, an installment loan is a loan that's paid off with regular payments, and so that's going to be most of the loans that we're going to talk about today. It's very rare that you find a loan that is not calculated for regular payments. And a loan term is just the time that you have to spend paying the loan back. So it could be a year, it could be 2 years, it could be 3 months, it could be, if you borrow some money from your parents, maybe they'll say, pay it back whenever, right? And so that time the loan term would be forever. Or I guess until they die. But okay. So installment loans are the kinds of loans that we're going to talk about today, and loan term is just the amount of time you have to pay it back. Okay. So this is the formula for how much a loan payment is going to be. Okay. Now you might see some similarities with so the homework for this one and the homework for the last one are both due, I want to say like on the 11th. Yeah. It says the 4th?
Yeah. Today, isn't it? Yes.
Man, I must have...
Slept all weekend.
Sure.
Yeah. Woke up at
That's...
email us.
Yeah, that's definitely what... You might remember that the formula for annuity payments, not that you need to know it here, but just to see how similar they are, the ways in which they're similar and the ways in which they differ. The annuity payment formula was equals it was P times 1 plus APR over N minus 1, well, to the NY minus 1 on top, and that same APR over N on the bottom. So if you just compare these two, you can sort of see how similar it is. You can just sort of see that the top and bottom are sort of switched with each other, and instead of this whole thing minus 1, it's 1 minus a different whole thing. Different only in the fact that the exponent is now negative. It's negative ny instead of positive ny. So just if you wanted to look at them next to each other, here they are. So, and this has to do with the fact that they work much in the same way, just that the interest is sort of funding your payments and that you're working to decrease the balance, not increase it. But the fundamentals of how the interest accrues and stuff is still the same, which is why many of the terms and expressions that appear in both of them. But this is what we're going to be. This here is what we're going to be using today for talking about loans. Okay. So, just at least this is the labels are right here, right? But this is the payment amount. This is the principal of the loan. This is the amount borrowed. Label it. It's the amount that you borrow in the very beginning. APR is the rate, the interest rate as a decimal. This is the payment periods per year, same as in the other formula, right? So all these variables are actually the same. They're just put together in a very similar but slightly different way. Payment periods in a year. So that is for, monthly payments, and is 12. For quarterly payments, and is 4, and so on. Right? It's just how many of those there are in a year. And Y is the number of years that you have to pay it off. Right? I'm not going to. So N appears several times, and so does APR, but I'm not going to point to them all, because they just mean the same thing wherever they appear. Okay, but all these things mean the same, as they did before. Right? PMT is still the payment amount. Principal, well, it's a little bit it's the amount you want to pay off or to save up to, right? In this case, it's the amount you want to pay off, it's the amount you borrowed in the loan. But then the APR is still the interest rate, and N is still the number of payment periods in a year, and Y is still the number of years that you have to pay off this amount. That's all there is. That's all there is to know about loans. Obviously, using it, but that's the only formula involved. Okay. So you may have noticed that the way we talk about it, the payments are the same throughout the life of the loan. Now this seems weird because as the balance of the loan goes down, you'd think that your payments would be less. But the way it's calculated in the very beginning, for ease of the person paying it off, ostensibly, it's actually calculated so that over the life of the loan, you're sort of paying it off with equal payments, because that's easier for people to handle. And the way that works is simply that early in the loan, so throughout the life of the loan, your payments are going to go towards different parts of it, right? Some parts of your payments are going to go towards the interest, and some of it is going to go towards the original loan balance. The way it works is that early in the loan, most of your payments, right, the bulk of your payments are just going to go off to paying off the interest that big loan amount is accruing. And it's going to sort of slowly whittle it down until, it's smaller. And because it's smaller, it's gaining less interest over time until it's almost all paid off. And towards the end of the loan, you're mostly going to be paying off the actual principal. You're going to be paying off the actual part that you borrowed. And not much is going to be going to interest. So early in the loan, right, most of your payments are going to be going towards interest. Later in the loan, most of your payments are going to be going towards the actual principal. But the way that they shift that is sort of how they can keep the payments equal over time. Because if you wanted to pay the same proportion towards the interest and the principal all the time, then your payment amounts would be changing like as the loan continues, and that would just be confusing for everybody probably. But yeah. Early on, most of it's going towards interest. Later on, most of it's going towards the actual principal. Okay. So, suppose you have student loans totaling $7,500 when you graduate college.
Let's change the number to 17,000.
Yeah.
Me and zero. He's like,
I could pay by the number.
Yeah, as the part of the what do they call it?
Hazelwood.
Oh, okay. Yeah.
Thank you for the Texas veterans.
Right. Oh, that totally makes sense. Yeah. I mean, I could certainly think of a couple years I've wasted in my life that I could have spent on, I guess, being in the military. Yeah. So this is the loan amount, meaning that this is P. This is the amount borrowed. Okay. The interest rate is 9%, which if you want to write it, which you do, yeah, you can take that and take 9% and divide it by 100%, or just 9 and divide it by 100. Either way, you'll get 0.09. That's your value of R. Loan term is 10 years, so that means...
loan term is forever.
So Y is 10. Let's see. It talks of monthly payments, so that actually implies that N is 12. Okay. So that's the first question. What your monthly payments are? And once we know that, we can answer the other questions. Okay. So let's see if I remember that correctly. The loan payment formula that we're going to use has P times APR over N on the top, and on the bottom has, I'm going to use a square bracket just to differentiate it from the parentheses that's going to be in there. 1 minus 1 plus APR over N to the negative NY. Now I believe that is correct. Okay. So, throwing all those numbers in there, let's see. So 7,500 times 0.09 over 12 all over 1 minus 1 plus that same 0.09 over 12. To the negative NY. N being 12 and Y being 10. And just to be safe, I would say wrap this up in parentheses right here in the exponent. Okay. So let's see if we can't simplify that a little before putting it into the calculator. Of course, you can probably, if you are very careful, put this into the calculator by itself, but maybe not the safest thing to do. So if you calculate 0.09 over 12, yeah, it's sort of like a 3/4 except with a bunch of zeros. 0.09 divided by 12, yeah, 0.0075. Okay, so 0.0075. Yeah. Well, you can even say 0.0075. Always forget to put the leading zero. Of course, nobody has to put leading zeros, but sometimes they look nicer, and sometimes they make things line up better. So 1 minus 1 plus the same 0.0075. Power of negative, well, that'll be negative 120, won't it? Okay. So you could even take this a little bit further and just combine that 1 and that 0.0075. I should do that in blue, I suppose. 1.0075. And then raise that to the power of negative 120. Okay. And that's probably the simplest as you're going to get it, I suppose. I mean, you could probably, but that's probably pretty reasonable. Okay, so 7,500 times, well, I suppose you could just put a parentheses, do 0.0075 divided by 1 minus 1.0075, all raised to the power of negative 120. And drop down from the exponent if you got one of those. If you got one of those calculators that sticks you up there, close the parentheses and press enter. And so that's all here, right? That's, of course, if you want, so if you want to make it simpler to put in, you can definitely do that. Okay. Of course, there's nothing preventing you from putting it in exactly like this, I suppose. Let's give that a shot. 0.09 divided by 12. Okay, that divided by I'm going to use a parentheses, like a big parentheses, 1 minus, parentheses again, 1 plus 0.09 divided by 12, close parentheses, close one of the parentheses, divided by negative 12 times 10, drop down and close the parentheses, and hopefully it should give me the same thing. Yeah, so you could put it in all at once or simplify it in pieces to make it easier to Now, there is a way that you can use the same PVM solver that you used for savings plans for loans, right? Okay. So early on, I wanted to make it clear that for savings plans or annuities, you started with a balance of 0 and tried to build it up to some amount. Whereas with loans, you're going to start with some amount and you're going to try to whittle it down to where it's zero. So that's going to change what we're doing in a lot of these things. So let me actually just take this and I'll show you what we would do to use this. This is a real pencil. Okay. So n is going to be the total. Is again going to be the total number of payment periods, or just the total number of payments. This is n, just n times y. This is the interest as a percentage and not as a decimal. This is the present value for the loan. Which at the beginning of the loan is going to be the amount borrowed. So you might remember that for savings plans, this was zero because we start off with no money. Here it's actually going to start off with some amount of money. This is the payment amount. The PMT is the payment amount. And the future value should be zero. Because you want to pay off a loan, right? You eventually want to make the loan be worth nothing, right? You want to have paid it all off. You don't want there to be any outstanding balance. And this is the payment periods in a year. It's just your n. Okay. So if I recall, for our particular problem, the present value of the loan was not zero, but rather 7,500. And the interest as a percentage was 9%. The total number of payment periods were 10 years, and it was monthly, so we do 12 times 10. You can literally just write 12 times 10 in there, or you can write 120. Payment amount we're going to be solving for. No. And the future value should be 0. It should always be 0 with a loan. And the payments per year should be 12. And when you change one, the other should change. And I believe that should give us the correct payment amount. Present value being 7,500. Future value being 1. Present payments per year being 12. Okay. Then what we're looking for is our payment, so you press alpha, the green button, and the enter key because that says solve over it, and you'll see that it comes up with the same payment amount that we got through using the, that whole formula, right? But either way you do it, right? Payments are, the monthly payments are about $95, so that's $95 a month, damn. So if you set aside $95 a month, you can get the loan that you took out for $7,500. You can get that paid off in 10 years. And sometimes they're necessary. They're generally inadvisable. Okay.
Yeah.
Let's see. Okay, so let's throw in a new slide and answer those other questions. So the payment amount. So the payment amount either through the formula or through this sort of solver here is $95. $95.01. Okay. Let's go right here. Yeah. Okay. So the payment amount is $95.01. Just making sure that I was correct in rounding it to 1 cent instead of just the nearest dollar. Okay. So, if your payment amount is $95.01, what's the total amount you'll pay over the 10 years? That's going to be the payment amount. Well, this is the PMT, right? Okay, so payment times the total number of total payment periods. Which is just NY. So as you might have seen, the total number of payment periods is 120 from here. Or if we go back to where we wrote it in, you'll see that it's 120 that way as well. So either way, you can just grab the total number of payment periods from this exponent or from when you solved it for this n. So that's 120. But they're going to be 120 months, 10 years, monthly payments, that's going to be 120 months. So that's going to be $95.01 that you're going to pay 120 times. Right, and that 120 comes from 10 years and monthly payments. 12 times 10. And so the total amount that you're going to pay, if you pay it off this way, it's 120. It's actually not the $7,500 that you borrowed, but more than that. It's going to be $11,401.20. So the longer you take to pay off a loan, the more you're going to pay in interest, and the more past the actual amount that you borrowed that you're going to have to pay back. Right, so this is the amount that you're going to have to pay. If you want to know how much of it is interest, you just subtract away the amount borrowed. Right? Of course, some of this is that $7,500 you borrowed. But the rest of it, whatever the rest of it is, will be interest. take the total amount that you paid, subtract away the amount that you borrowed in the very beginning, and whatever the difference is, whatever is left after you subtract away the amount that you borrowed, that's going to be the amount of interest that you paid. Take 11401.20, subtract away that $7,500 you borrowed. Almost $4,000 in interest. Definitely more than half. So 3901. So you take the total amount paid. After figuring that out by multiplying the payment times the number of total payment periods, you take that amount, you subtract away the loan principal, the amount that you borrowed, and you should get the interest. Okay, so that answers the question of, what are your monthly payments, how much will you pay over the lifetime of the loan, and what was the total interest you will pay on the loan, right? Total payments are, the payments that you'll be paying are $95 a month, $95.01 a month. The total amount you'll pay over the lifetime of the loan is quite larger than the actual amount of the loan. It's $11,401.20. And as for how much of that is interest, just subtract away the $7,500 that you borrowed, and the rest, right, will be interest. So you end up paying like $3,900 in interest. Okay. Right, just plug this in like that. You get 95, multiply it by 10 times 12, or 120. You get 11,401, and then at the end you subtract away the 7,500. You get 3,901 and 20 cents, give or take. Okay. So this is simply a table. You won't have to, you won't have to really go through it. But what this is meant to illustrate is how much the difference is as for how much of the payment goes towards the principal and how much of it goes towards the interest. Okay. So of course it's easier to use software, but let's just take a look at this. So we look at the first month, right? The interest is going to be 0.0075 because that's the 9% APR divided by 12, right? That was the 0.0075 that we got. Multiply that by the outstanding balance, which at the first month is still the whole amount, right? And that's going to be $56 of interest. So, of course, your payments are the same. They've been pre-calculated. They're $95.01 every month. But the interest on the outstanding balance is $56. So, $56 of it $56 of your payment goes towards the interest, right? And the rest of it, whatever the rest of it is, goes towards the principal. Right? And then you just subtract away that tiny amount to get the new principal. Then the next month you start with that amount, right? A slightly lower principal. You multiply that by 0.0075. Right, and so you have to make a slightly smaller interest payment. It's smaller by the tiniest bit because you paid off a bit of the principal. And so since the interest payment is smaller, slightly less of your payment goes towards interest and slightly more of it goes towards the principal, meaning that you pay off a little bit more of it this time, decreasing it even more. And this continues, right? So now your principal is $7,422.19. You pay the same rate of interest on that, but it ends up being less because the principal has been decreased. And so now you only have to pay $55 in interest. And so $55 of your payment goes towards interest. The rest, now a bit larger, goes towards the principal. And so you're paying off more of the principal. So as time goes on, of course, in the beginning, it's mostly towards, your payments are mostly going towards the interest. But as you slowly whittle down that principal with the part of your payment that is going towards the principal, as you slowly decrease the principal, your interest payments will be less, your principal payments will be more, and that'll just continue until you're paying almost very little of it is going towards interest and most of it is going towards the principal. But in the beginning, it is a relatively high proportion of the payment that goes towards interest. Okay. So that's just the idea behind payments on a loan. Okay. Now credit cards are functionally loans from the bank for you to, you're borrowing money from the bank to buy this thing and then you're going to pay it back. The only way in which they're different is that the period in which you pay them off is not predetermined. You can pay it off that month, you can pay it off the next month, you can stretch it for years probably, although, that's sort of functionally discouraged by the relatively high interest rates that credit cards have. But that's the difference, right? You're not required to pay it off in any set period of time. You can pay it off as soon or as late as you're willing to do so. They do require a minimum payment. It's usually some small amount, but you should probably pay more than the minimum payment every month. If you're not paying it off in full every month, that is. And so that minimum monthly payment generally is just there to cover the interest, right? To make sure that the amount doesn't get any higher than it already is, right? It won't decrease it, but it'll keep it from increasing if you pay that minimum monthly amount. You should probably pay more than it because you want to eventually want to probably pay it off completely. And so because the minimum monthly payment mostly goes towards the interest, if you only pay the minimum monthly amount, it takes a very long time to actually decrease the principal on a credit card balance. Right, so you should seek to pay more than the minimum monthly amount so that you can actually decrease the balance, not just pay off the interest. Okay. So, let's see. Suppose you have a credit card balance. So you get to decide how long the term of the loan is, right? But functionally, it is the same as a loan. You just get to decide the term. Okay. Credit card balance of $2,300. That is the loan amount, P. An annual interest rate of 21%. Of course, as a decimal, that is, that's 21% divided by 100%, or just 21 divided by 100, or 0.21. You decide to pay off your balance over 1 year. So this means that y, the number of years, is simply 1. How much will you need to pay each month? That means you're making monthly payments, so that n is 12. And how much will you need to pay each month? Well, the fact that that's asking that question means that we're wondering what PMT is. That's what we're trying to find out. Thankfully, that's what the formula is sort of solved for. So that loan payment formula is P times APR over N all over 1 minus 1 plus APR over N to the negative N times Y. So throwing all those numbers in, the amount of the loan, right, is, actually let me just do this. Okay, so the loan amount, P, is loan amount P is 2,300. APR is 0.09. No, it's 0.21, right? 0.21 divided by N is still 12. And you'll find that that's the case with a lot of these because the implication is that you make monthly payments. Because that's just that's just how it is in most cases. You make monthly payments on loans like this. 1 plus the same rate, 0.21 over 12, to the power of negative ny, so 12 times 1, because it's just going to be the 1 year, for a total of 12 payment periods, right? 12 times 1 is 12, so I have a suspicion that this 0.21 divided by 12 will not be a nice neat number like it was for the 0.9. So if you wanted to simplify this, no, it's not terrible. Okay, 0.175, not bad. So 0.21 over 12, this fraction, simplifies to 0.0175. So you can do that. 2,300 times 0.0125. 0.0175, what am I saying? Yeah, 0.175. Over 1 minus 1 plus 0.0175, all raised to the, and you can even simplify 12 over 1 to 12, so that's going to be to the negative 12 power. Which you can even further simplify if you combine that 1 plus that 0.0175. So that's 2300 times 0.0. One minus 1.0175 to the power of negative 12. Okay. So let's see, 2300 times, oh, I guess I should do that in parentheses, 0.0175 divided by, open parentheses, 1 minus 1.0175 raised to the power of negative 12. And just drop down and close that parentheses. And so if you simplify it, you only have to have really 2 sets of parentheses. I guess one for multiplying on the top, and then one just to contain the whole bottom, if you simplify everything as far as it will go. That will be $214.16. So those are the monthly payments. Right? In order to pay off a balance of $2,300 in 3 years, or in 1 year, with that interest rate, you'll have to make a payment of $214 every month. Now, of course, you could also, right? You could doing this instead, right? You could, let's just put 0 for all these. Okay. So the number of payment periods is just, it's monthly, there's 1 year, it's that same exponent there, that's 12. The interest rate is 21%. The present value is 2,300. Oops. Present value is 2,300. The future value should be 0. Payments per year is 12 since it's monthly, and so we just solve for the payment by pressing alpha and then enter. Get the same amount, $214.16. So if you want to do one or the other, that's up to you. If you want to do both to check that you're doing it correctly, that's also, it's also fine. But what you have here is literally just the same thing as what this is doing. Like, it's just taking these numbers and throwing it in here, in order to make that happen. So, just whichever one you would prefer to use. I would say this is easier, maybe less foolproof. It just takes a bit of doing, but it doesn't even take that much practice. It just takes doing it a couple of times to sort of get the hang of it, get the hang of which one you're doing. And we'll talk about the differences between what we're talking about today and what we talked about before in a little bit. Okay. So out of curiosity, if we wanted to know exactly how much more we'd be paying, you can take that amount, $214.16, and just multiply it by 12 to find the amount you would pay over the year. You'd pay, not amazingly more than the $2,300 that your balance was, right? Only a little bit more, like $269 more, $270 more. So it's not super egregious because you didn't take 10 years to pay it off, basically. So you only have to pay about like $270 in interest because you paid it off in such a short amount of time. Right? The longer you take to pay something off, the more interest you'll have to pay. I'm just comparing this with the previous loan that took 10 years. And then these are just little vocabularies. So a mortgage is literally a loan that it's specifically designed for a home. A down payment is or the price that you just pay off upfront, right? You pay it in cash, or you just pay it off, and so you don't have to borrow money for the amount that you've already paid. Clearly, so like let's say there's a home that's, I don't know, $300,000 or something. Let's see. Let's say there's a home that's $300,000. If you make a down payment of let's say $30,000, right? Theoretically, only have to pay. Well, only have to borrow, right? Yeah, you don't have to borrow the remainder. Right? So the idea behind a down payment is that it's some amount of the price that you're paying off immediately, and that you won't have to borrow to pay, because you have the money. You're giving up the money up front. Right. So clearly, it's relatively intuitive. If you pay something up front, like right away, you won't have to borrow it, and you won't have to gain interest on that amount of it if you pay it off immediately. If anything, yeah. All right. Now, fixed rate mortgage is just one that is not going to have its interest rate change over the life of the loan. And a adjustable rate mortgage, on the other hand, is one where the interest rate can change based on what the interest rates are like around you. So, just if you think you can get a better interest rate than what's around, then you should go with a fixed rate mortgage. Otherwise, if you can't get a better one, then it might be the case that you're just stuck with a higher interest. Even if interest rates go down, you'll be stuck with a higher one if you can't get a particularly good fixed rate mortgage. All right, so let's see, 35. Yeah, no, 40. 40. Okay. Let's see. Okay. I'll start at 110. It goes to 135. Yeah. Alright, so let's spend the next 18 or so minutes let's see, calculating some more annuities. Okay, so actually let me talk a little more about using the TBM solver. Let me just grab this, throw it here. Okay. So this is going to be the difference between... Okay. Let me just solidify the differences between... Okay. So this... for an annuity and a loan or a mortgage or whatever. Yeah. So like I said, in an annuity, the interest is going the same way as your payments. In a loan, the interest is going the opposite way as your payments, right? You're trying to make payments to decrease it. The interest is increasing how much you have to pay. Okay. So So in both of these, N and I are the same. Total payment period. Total payment periods. Or, well, I mean, you can just call it the total number of payments. I as interest, as a percentage, and it's that way here too. It's strongly encouraged you to use this if it is possible. A lot less error prone. Okay. For a savings plan or annuity, the present value should be 0. For a loan, the present value is the loan amount, you know, how much ever you borrowed. For both, the payment is usually what you're going to be finding, so just put a big old question mark. That's what you're going to be solving for. For a savings plan, the future value will be the desired, you know, how much money you want in the future. You know, whether you want $1 million or you want 100,000, that's the amount you're going to put here. That's the desired future amount. Whereas for a loan, the future value, you're going to try to get the loan down to 0. See, for a savings plan, the present value is 0 because you start off with nothing. In a loan, the future value is 0 because you want it to be nothing. And in both situations, this is usually going to be 12 if monthly, which they usually are going to be. And, you know, 4 if quarterly, 365 if you're making daily payments for some reason. But generally, it's going to be 12. Right, so really the only thing that has a different interpretation between these two is just which one you're putting as present value and which one, you know, what you're putting as present value and what you're putting as future value. Right, just remember for a savings plan, you start off with 0. For a loan, you want it to end up at 0. Okay. All right. And so, of course, you want to identify all these pieces, right? But interest rate is 3. Monthly payments, so payments per year is 12. The long term is 20 years. Payment amount is 7. Okay. Okay. So as for how many payments does a total loan require, it's monthly payments for 20 years. So all that means is that you can take 20 years and multiply it by 12 to find out the number of months that are in 20 years. And so there are 240 months, so there are 240 payments. And the total amount paid, you just take the payment amount, which it has so graciously given to us, right? 471, and multiply it by the number of payments that there are going to be, right? Each payment is going to be $471. There are going to be 240 payments overall, and so the total amount paid is $113,040. And that's just from taking the payment amount and multiplying it by the number of payments that there will be, right, over the life of the loan. Okay. Now, as for what percentage is paid towards the principal, so this is the amount that you're going to pay, right? Some of it is the principal, some of it is the some of it is the $85,000, right? And then some of it is the interest, right? Clearly, not all of it is the $85,000 because it's much more than $85,000. If you want to know how much of it went towards the principal, just take the principal and put it over this amount to find the proportion of the $113,040 that goes towards the principal. So that's about 75% of it. So you can also multiply this by 100 to get the percentage, like 75.2%, right? Oh, I guess I don't need to list the percentage. And let's clear that. Okay. So this is the amount we paid. So if you want to know the percentage paid for interest, you can do 100 minus 75. The easy way is to do 100 minus whatever this is, because, you know, they're going to add up to 100, right? So that's, you know, that's the easy way, 24.8. Okay. So again, you're going to have to do this percentage thing at the end, but you know. Ultimately you can throw all these numbers into here and you want to write a thing down, but you have to know what you're doing. Okay. So the implication is that there are monthly payments, so it is months, right, that you're paying for 30 years. So the total number of payments will be 12 times 30, right? 30 years, every month, that's 12 times 30. You just move off of that. That's going to be 360 payments. Let me just put 0 for all the others so that it's not particularly confusing. Okay, so 12 times 30, that gives you 360 for the total number of payments. The interest rate is 12. If you're using this, you just use the number 12. Present value is the amount that the loan is for, that's $25,000. Future value should be 0, and we're going to look for the payment and just make sure that the payments per year is 12, if it's not already. Okay, but you can solve for the payment amount. And so the payment amount per month is going to be $257.15. Yeah. $257.15. Obviously, it'll be, you know, slightly different for you, but so just use that number, $257.15. That's the payment amount. Just take that number and multiply it by, in this case, 360, right? Because there were 360 payments, right? That 12 times 30. So 360 payments of this amount is going to amount to $92,574. That's, wow, 2. Okay. Which is particularly egregious given that the loan was for $25,000, right? This is almost 4 times as much. So, yeah, it's possible that if you take 30 years to pay something off, you can pay 4 times as much just due to the interest alone. So, what percentage is paid towards the principal? We'll take the principal, $25,000, and divide it by that total amount. So that's around 27%. And if you want to know what the rest of the percentage is, you can just take 100% and subtract the 27%. Right? Because they had to add up to 100. So that's 73% towards the interest. Okay. So you can, I would recommend using this, right? It's a lot easier. But you definitely could use, where is it? Yeah, you could still use this if you wanted, particularly if you're careful about how you arrange things in your calculator. But there are a lot of pitfalls. There's that exponent, there's this sort of nested parentheses, there's this sort of thing on, having all that on the bottom of a fraction, having a fraction on top. But if you are going to do this, then what I would definitely recommend is simplifying it piece by piece, like writing it all out, first, and then simplifying, particularly this fraction, the APR over n, simplifying that first into being a number, which you can then combine with the 1, and eventually get it to something like this, right? This is a lot, and also simplifying the ny in the exponent into one number. That way, there's a lot less places to mess up here if you just sort of simplify it piece by piece, even though it is, more to write. This is definitely what I would recommend.